Welcome, everyone. I'm Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are thrilled to welcome you to today's event, Google Cloud Analytics, from data collection to visualization. Presenting today's topic is Geetika Sethi. Geetika is a seasoned professional with over 10 years of experience in research and teaching. She specializes in GCP data analytics, covering data lifecycle management, solution architecture, and data visualization using Looker Studio as well as other tools. Her expertise extends to ML AI-driven analytics, focusing on prediction, automation, and pattern recognition. She has successfully delivered numerous corporate and academic trainings with excellent outcomes. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. This webinar explores the fundamentals of data analytics using Google Cloud tools. Designed for professionals across industries, it will provide practical guidance on using BigQuery, Dataflow, and Looker to collect, process, and visualize data effectively, turning raw data into actionable insights. I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Geetika, thank you so much for joining us today.
Thank you, Tracy. Today we are having our masterclass on Google Cloud Analytics, from data collection to visualizations. I would like to introduce myself as Dr. Geetika Sethi, a data scientist and a cloud computing professional with experience in data analytics with 13+ years. Moving forward, today's agenda includes the following topics. First, we are going to have an intense understanding of the ecosystem that permits and allows to perform data analytics on the Google Cloud platform. Followed by that, we are going to discuss data collection and ingestion, talking about how the data from different sources is first assembled and then imbibed or incorporated into the GCP system for data analytics. Next, we will be looking at data processing and transformation processes, which include the cleaning of data, which include removal of duplicates, and how the data has to be shaped to make it compatible with the downstream use cases or the outcome that we expect in our data analytics scenario. Overall, in step number 3, we built a pipeline that allows and permits to accomplish the ultimate goal that our analytics task holds. Followed by this, we are going to wrap up our session with the last 2 modules, where we are going to discuss the core data analytics processes, and we will also be working with ML/AI integration examples and the real world scenarios. And the last stage of this complete agenda is going to be data visualization, where we would see how the graphs, the plots help us to be empowered to be comprehending the data in an effective manner. So let's get started with the first section, which is introduction, where we are going to understand the complete ecosystem of different services that allow us to achieve the complete pipeline of the data analytics tasks and scenarios. So the first service that we want to discuss is BigQuery. And the 3 core points about BigQuery are: number 1, it is serverless and scalable. So what do we mean by serverless and scalable? Serverless means that it is a fully managed service. That means the complete graphical user interface and the command line method of interaction through the SDKs, the software developers kit, is readily available for the users to implement for their data analytics task. And scalable means that it can be scaled to accommodate large data sets, which would be reaching to the size of petabytes and exabytes. And this scale up happens automatically in an automated manner, and that is what makes it a managed service. Furthermore, BigQuery permits us to perform fast SQL queries. So SQL stands for Structured Query Language, and through SQL implementation, we can query our data. And when we query our data, we mean that we are asking interesting questions and impactful questions to our data. The answers to those questions can empower our businesses, can empower our decision-making processes, and overall give us insights about our data. The last point about BigQuery to conclude at this stage, at the introduction stage, to talk about BigQuery would be its most interesting capability, which is that it can be integrated internally with multiple services within GCP. Furthermore, it can also be connected and integrated with services outside of GCP. Hence, this is an important player in the ecosystem of Google Cloud Analytics. Let's come to the next one, cloud storage. This is no less, and the three core points about Google Cloud Platform provided cloud storage service for the cloud analytics ecosystem are as follows. The first key point is the durability and security. The cloud storage service stores data reliably, and also there is a built-in encryption and high availability across multiple regions across the globe, thereby making it a durable and a secure service for our data analytics task, which incorporates data storage big time. And let's not forget to mention that data storage is an inevitable task in the analytics pipeline. At some stage or the other, I repeat, at some stage or the other, data storage will have to be performed to store our data that can be fetched any given time for the usage. Coming to the next player in this ecosystem is data flow. So this is a super interesting one. Let's see how. So the core points to be considered for data flow are as follows. First, it permits both streaming data and the batch data processing. The streaming data processing implies that the data is live. The examples in the real world scenario that would include the live streaming data would be from IoTs, Internet of Things, where, say, for example, the sensors would be collecting the data and transmitting the data live to the data analytics pipeline, where the service like data flow is quite compatible to receive that streaming data for the downstream processing purposes. Followed by this, we also need to know that data flow is equally compatible for the batch processing of the data. And when we mean the batch processing, in this scenario, the data is not fixed. The data is not streaming. The data is fixed. And an example would include the data sets from a given bank. So let's say there is a financial institution like a bank, which is like recording 30 years of daily transactions, and these transactions are getting stored in a given database. And now this complete data set of 30 years is going to comprise of a batch data set. So to process that batch data set, data flow is the compatible service in the Google Cloud Analytics ecosystem. The next key player and an important one is the PubSub. And for PubSub, the service needs to be mentioned for its highlighted feature to permit real-time messaging, releasing the notifications. Also, this service has the power to build or to help build the decoupled services, which would mean that the multiple services that are part of the Google Cloud Analytics pipeline can be connected through the PubSub messaging system. So overall, the data generators and the data processors can be separated, they can be decoupled because of this unique service, which is the PubSub service. The last and most important feature that deserves to be mentioned is that the scalability is possible for PubSub services. And scalability would imply that large amount of data can be transmitted through PubSub as messages to the receiver services downstream. Followed by this, we are next discussing the key points about Looker Studio. The Looker Studio is currently and recently being named or is being called as Looker Studio. However, previously it was called as Data Studio. This service permits to build interactive dashboards of the graphs and the plots for data visualization. So the above key players are instrumental in permitting the complete steps until the analytics, but this guy is quite catalytic to permit data visualization, which is an empowering input for the complete data analytics pipeline, because visualization empowers us to be able to comprehend outcomes of data analytics in a better way. Followed by this, we can summarize this complete section of discussion related to Google Cloud Analytics ecosystem by highlighting the importance of cloud-based analytics. The first key point is that the Google Cloud-based analytics permits a scalable system to be built for the analytics tasks. That means with fully managed services, the large amount of data can be ingested, processed, stored, analyzed, queried, visualized, as we have discussed in the above steps, to ultimately achieve the goal of the analytics task. Most importantly, the complete implementation is cost effective as we pay as we go. That means the model of the charging system for GCP is to pay as you go. This implies that whatever services will be utilized for whatever duration and capabilities, accordingly, the payments and the commercials would be charged. Followed by this, the conclusive point about this section would be that through Google Cloud's analytics ecosystem, effective data analytics can be achieved, which would permit real-time insights to be derived and collaborations to be made with the collaborators within the organization as well as outside of organization. All the steps and implementation and the services that we have talked in this particular section of introduction are inclusively labeled under data lifecycle management. So when we head forward for Google Cloud Analytics, we are directly or indirectly heading for data lifecycle management, DLM, that involves multiple steps, multiple tools, multiple services and multiple tasks before we can actually analyze our data effectively and visualize the data. The first step of this data lifecycle management is data collection and ingestion. For data collection, we are aiming to collect the data. And for data ingestion, we are aiming to bring the collected data to the GCP platform. The collected data could be coming from different sources. It could be coming from the web, the internet, which could be involving, say, for example, social media activity. Another source where the data could be coming from is the data from the apps or the applications, which could be the in-house applications of a given organization, or these could be the open source applications. Followed by this, the last example, which would be offering the data sources, or which could be offering data sets for data analytics, which have to be first undergo the process of collection, is going to be IoTs. So these are going to provide us real-time data. For example, the smart devices that offer the data from the sensors, as already discussed in the previous section. So this data, which has been collected from different sources, is now ready for ingestion. The tools that permit ingestion can be multiple in number, and 3 examples are shown on the screen. We will not discuss all of these because we have done these 2 already in the previous section, but let's pick up this particular one, which is a GCP transfer service. The GCP transfer service allows data migration. It permits large amount of data sets to be transferred from on-premise. On-premise means local environments to the GCP cloud ecosystem. These are also implemented to transfer data from other cloud platforms like Microsoft Azure, AWS, Amazon Web Services to be bringing the data into the GCP ecosystem. The next important strategy that needs to be discussed for data ingestion is related to real-time data ingestion. As we've already discussed, real-time data is the data which is live data. It is not the fixed data. So the strategies that permit us to perform real-time data ingestion include as follows. The first one is the stream processing strategies. That means the live stream of data is being considered from a given source of data like IoTs, and accordingly the stream processing tools are implemented. So the example of stream processing tool would be Cloud PubSub. The next scenario would be the batch data ingestion strategies. And for this, typically the examples would include, number 1, the cloud storage uploads. That means, going back to our example of 30 years of fixed data or the batch data from a financial institution, for example, a bank that is recording daily transactions of its users, of its clients in a given database, and that data needs to be ingested. So in this scenario, the cloud storage uploads would be implemented to allow ingestion of this batch data into the GCP ecosystem. Another example of the ingestion strategy for the batch data includes the BigQuery data transfer service. So this BigQuery data transfer service allows automation of ingesting these batches of data from the sources, which could be, for example, the on-premise sources or the third-party platforms or any cloud platform as well. To sum up and summarize this particular section, let us pick up the real-world scenario examples which can help us to understand the data collection and ingestion step of the data lifecycle management in a better way. So the first scenario, which serves to be an excellent example, would be the e-commerce website. So this website is going to collect and ingest a lot of data. For example, the user click streams, the user purchase history, the product views, etc. The next example of a real-world scenario that allows us to understand the data collection and the ingestion processes would be the smart city traffic monitoring. So the smart city traffic monitoring is going to be ingesting the data from IoT-enabled traffic lights. So these two examples in the real world scenario provide us with the insights about data collection and ingestion as the core important step in the data lifecycle management, much before the data can be taken forward for analytics. Having discussed the first step of data lifecycle management being data collection and ingestion, we saw how the real-world scenarios of e-commerce, a website, or the traffic systems involve data collection and ingestion in an effective manner. Followed by this, the next step in the data lifecycle management is data processing and transformation. When we talk about data processing and transformation, we are trying to discuss the implementations or the key implementations in GCP that would allow us to achieve the tasks of processing the data and transforming the data. That means overall shaping the data in a way that is going to be compatible with the tools and the services and the use case that we are trying to accomplish. So the key implementations in GCP for data processing and transformation include the data flow and the data prep based implementations. So the data flow is a service that is going to allow both the stream data processing and also the batch data processing. So by implementing data flow, we can build the scalable pipelines that clean, that filter, that aggregate our data sets and overall allow our data sets to be enriched so that the given data set can be taken forward downstream for the purpose of data analytics. Furthermore, apart from data flow, BigQuery is also helpful to allow data processing and transformation. So overall, we can see the three core implementations are data flow, data prep, and BigQuery that overall help and allow us to achieve the finally shaped data after processing and transformation, which is ready for now to be taken for the data analytics task downstream. So let's dive deeper into each of these key implementations, the data flow, data prep, and BigQuery one by one to see how they actually allow the processes of data transformation and the shaping of the data to be accomplished. So the first one is going to be the data flow that we are discussing. So it is allowing us to permit to build scalable streams. It is allowing us to perform batch processing. It allows us to integrate tools like Apache Beam that is going to allow overall data processing tasks to be accomplished. Followed by this, data flow is quite friendly to permit automatic resource management, which allows the auto scaling of the compute resources needed for the complete data processing and transformation. Followed by this, let's dive a little deeper into data prep to see how that helps us to achieve data processing and transformation. So the key points through which we will be able to understand better as to how data prep is helpful are as follows. So first thing first, this service allows us to achieve visual data preparation that is going to provide a no code or zero code interface to clean the data, to enrich the data, and to transform the data before the data gets loaded to the analytics tools like BigQuery. We have already discussed that in first section, the Google Cloud ecosystem section, right? The next important point that bolsters the fact that data prep is helpful in data processing and transformation is that this service can be integrated with multiple services within GCP itself. It can integrate it with cloud storage, BigQuery, and other GCP services to allow easy import and export of the data sets, which can then be integrated into larger pipelines. The last key point that is going to help us to understand the same is going to be that automated suggestions and scheduling can be performed on data prep service, which internally uses powerful ML machine learning systems to suggest data transformation. These suggestions empower the user to be able to handle the data processing and transformation tasks in innovative ways. And overall, the scheduling of these data prep workflows are supporting both one-time and recurring jobs, which implies that the jobs or the tasks that have to be performed in a repetitive manner, let's say every week or every day or maybe even every hour, those tasks can be easily automated on data prep. Now let's see how BigQuery is helpful for the tasks of data processing and transformation. So the first implementation is for the ETL, and ETL stands for extraction, transformation, and loading. So BigQuery platform is a SQL-based platform where the query writing can be done, or SQL or structured query language scripts can be written to process the data, for example, to remove the duplicates or to remove the null values, etc. Furthermore, BigQuery allows integration with data flow and cloud storage. So this is going to not only effectively allow data ingestion that we have discussed in the previous session, but also it allows smooth extraction of data and the loading processes within the ETL pipelines. Followed by this, BigQuery offers high performance and scalability that can be leveraged to achieve the tasks of data processing and transformation. Let's now switch gears and talk about the steps or tasks in data processing and transformation, which each of these services help us to accomplish. So the first step or the first example of such task is data cleansing. Data cleansing involves, as we discussed, removal of duplicates, removal of null values, or removal of values which may not have unique identifiers and are of less value to the data set overall, or any chunks or pieces of data which are not needed for the given use cases. So BigQuery-based SQL implementation, that means SQL scripts or SQL scripts can be written and implemented to cleanse the data. Furthermore, BigQuery allows automated data checks which can be done. And what kind of data checks are we talking about? We are talking about the quality checks. So with integration with tools like Dataform or Data Catalog, the rules can be set up to perform data cleansing, to enforce data quality and consistency across the pipelines. Now let's shift gears to discuss the data enrichment tasks in the step of data processing and transformation. And when we talk about enrichment, we are indicating the examples of the tasks like joining the data sets with other valuable data sets which are going to enrich the data overall, making it more valuable for the process of analytics. Followed by this, another example for data enrichment would be using the data flow for real-time enrichment. That means the streaming data and the data sets which are live, they can be enriched on the fly. That means as and when they are streamed, they can undergo the enrichment processes through the enrichment pipelines, which are going to combine data sets from different sources, making the data sets larger, bigger, more valuable for the downstream analytics. And last but not the least point, which deserves the mention for data enrichment strategy, would be a machine learning powered enrichment with Vertex AI on GCP. So what do we mean by that typically? We mean that powerful machine learning models can be implemented through a service called as Vertex AI on GCP to achieve the predictive analytics, predictive classifications on the data sets, thereby adding more value and information to the existing data. The last example of the processes that are included under the stage of data processing and transformation is the schema design. So the schema design typically means, for example, looking at the column headers of a relational data set and then ensuring those column headers and the data types within those columns are compatible with our systems, tools, strategies, and approaches that we are adopting in our data lifecycle management, and more importantly, our data analytics systems. So for schema design, the processes would include denormalization of the tables for performance. So what are we indicating when we say the denormalization of the tables typically? So we are indicating that the data sets can be flattened. We can adopt these practices like flattening the data or denormalizing the data to overall improve the query performance, which would be implemented for the data analytics. Another example that is included under the schema design would be partitioning and clustering. So, for example, a data set can be partitioned by date, or it can be clustered by, say, user ID. So if we go back and refer to our e-commerce website data, so each user has its own sets of product views, and each user has its own set of shopping of the products it has done. So we can group the products, or we can group the data by user ID. So by doing that, we are organizing the data much better. And in a way, we are processing this data and transforming for making it more valuable for the downstream data analytics tasks. So what we have seen is overall that there are tools and services which allow data processing and transformation, like data flow, data prep, BigQuery are 3 examples. And on these tools, what kind of tasks are performed to permit data processing and transformation? So those tasks are, number 1, data cleansing, enrichment, and schema design. These are the 3 examples of the tasks that are included under the banner of data processing and transformation. And these tasks are performed with the help of the services data flow, data prep, BigQuery as the core services in this direction. Let's wrap up this section by picking up the real world scenario examples for data processing and transformation. So the first example would be the retail sales analytics. So the retail sales analytics would permit the data from the retail customers who have successfully purchased the products or the sales have gone through. So those data sets would be coming from multiple locations around the globe. Let's say for a given product, the retail sales data would be coming from Canada, and let's say Australia, let's say Africa, etc. So when those data sets are aggregated and they are processed and prepared for the downstream task of data analytics, we are looking forward to a scenario that permits data processing and transformation. And what kind of analytics would be then performed on such processed and transformed data sets? The kind of analytics would be, say, for example, product performance analytics. Let's say customer preferences analytics. Let's say seasonal trends analytics. But all of these analytics would be possible only and only when the data which was collected, ingested across the globe on different platforms is taken forward for processing, cleansing, transformation, and which may include enrichment, schema design, etc. With this, we wrap up this session with the last example, which is going to be the healthcare data integration. So this is an amazing example which necessitates to perform data processing and transformation. So let's say a given healthcare data experimentation is happening across the globe at different locations and sites. So the data has to be integrated from all those sites to a single hub, which is going to be the hub holding the data as a master database. So every single source site which is going to be submitting the data may be processing the data, transforming the data in a given format before the data can be submitted to the hub or the master database. Let's take a quick 5-minute break, and I'll start on the remaining topics after the break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off. Having discussed the core step of data processing and transformation, which is totally inevitable to shape the data in a manner to make it more friendly for downstream data analytics, we now come to the core topic of data analysis in Google Cloud Platform ecosystem. We will also pick up a very empowering integration, which is a machine learning integration in Google Cloud Platform for the purpose of data analytics, and how this empowers the user to fetch the results of predictive analytics algorithms and pattern recognition algorithms, etc. So let's begin. By now, from the previous sections, we already know that BigQuery is an important player for data analytics as it allows the implementation of SQL queries. And through these queries, we can ask questions to the data. And once we retrieve the answers, what we have performed is analytics, overall fetching insights from our data sets. Having said that, let us also pick up two core points about data analytics on BigQuery as of what makes BigQuery so special for data analytics and what makes it widely adopted across the world for the task of data analytics. So the first point is that BigQuery is a service that ensures high performance when it comes to data analytics. Its high performance is powered by the Dremel engine, which is using a distributed architecture that allows fast querying for the petabyte scale of data, and that too without needing additional indexing or partitioning. So this platform is powered by the systems that allow efficient data analytics, not only data analytics, but efficient data analytics. Hence, this is widely adopted across the globe and is a favorite choice of the data scientists, machine learning professionals, AI engineers to work on their data sets on the Google Cloud Platform ecosystem. Additionally, BigQuery is also powered by a feature of on-demand and cached results. By that, we mean we can run on-demand queries as and when needed, ask questions to the data as and when needed. The pricing also is going to be the per query pricing, and the results obtained from each and every query for the task of analytics can also be saved or cached, and typically we can implement the queries in a repetitive manner as well. So overall, for the task of data analytics on Google Cloud Platform, BigQuery is a favorite choice across the users around the globe. Followed by this, we also would like to throw light on Vertex AI and its power for its implementation for the process of data analysis. Vertex AI is a platform which permits machine learning integration for the purpose of tasks like predictive analytics. So, not only data analytics is possible in the GCP ecosystem, but also implementing the algorithms which are going to allow for predictive analytics through the Vertex AI is a feasible option as well. Followed by this, the Vertex AI also supports customized models that can be implemented and for both the training purposes and the testing purposes. It accommodates technologies implementing machine learning for data analytics. Followed by this, we then shift gears to know how the platforms like AutoML and BigQuery ML are further powering the tasks of data analytics. So, AutoML allows easy data integration with services like BigQuery, where we are able to implement no code or zero code machine learning model training. That means we can take machine learning models and train those models for the or using the data sets that are of interest to us for the use cases that are of interest to us. It provides a graphical user interface without writing any code, and users without any programming background can also leverage AutoML for the tasks of data analytics and machine learning integration. Furthermore, another powerful system, as we can see, is the BigQuery ML. So we can implement the BigQuery ML technology provided by GCP to integrate machine learning algorithms in our data analytics systems. Again, through this, we are implementing powerful models through the code writing being involved, and this can be implemented in the Vertex AI platform itself to achieve the machine learning based integrations for the data analysis. So overall, if you have to consider the real world scenarios for the tasks of data analytics and machine learning integration, or typically the data analytics tasks powered by machine learning integrations, those examples would be as follows. So the first one would be customer churn prediction. So on any given e-commerce platform, ML integrations on the data sets and the customer oriented data sets, the machine learning integrations can be done successfully to leverage the predictive analytics and to be able to predict the customer churn rates or the customer uh, uh, footsteps rates on those e-commerce applications. Another example in the banking industry would be the fraud detection in finances. That would mean the historical transaction a given set of users or the banking customers, whether their application, say for example, for the loan requirements would be categorized or classified as the fraudulent applications or the genuine and the true loan procurement applications. So overall, as we can see, through these set of illustrations on the screen, we can perform analytics on the services like Google BigQuery, and this can be leveraging data sets through, say, for example, Google Drive, which is going to be the source of the data, which can easily furnish data to BigQuery for SQL-based query writing. Followed by this, we can leverage advanced analytics and intelligence capabilities on GCP through its services like Cloud Machine Learning, Speech API, and Vision API. So these APIs represent application programming interfaces, which are the services readily available to the users to perform their machine learning based analytics on their data. Overall, these services, which can also further be integrated with collaborative services like Cloud Data Lab and let's say Cloud Data Proc, in total allow to create end-to-end data analytics solutions. These solutions are developed and built by business analysts, the data scientists, the developers, and machine learning engineers, AI engineers to overall perform and empower their existing solutions with these tools and technologies provided by the GCP Cloud Analytics ecosystem. The section on data analysis and ML integration clearly shows us the tools and platforms on GCP that can be leveraged for the task of the data analytics. And most importantly, they can be integrated with other tools and technologies within the GCP ecosystem to result in powerful solutions that can have impact on businesses by providing the insights based on which the decision making can be done. Once the data analytics implementations are done successfully, the next step in this complete pipeline is the data visualization. So what is this data visualization? By data visualization, we mean that the outcomes of data analytics, like, for example, the results from the BigQuery, which would be the tables or the relational data sets, can then further be taken for plotting the graphs or creating the visualizations like dashboards, which is going to be collection of the graphs, etc., to be able to comprehend the data better. So within the GCP ecosystem, we can take the complete end-to-end implementation successfully for until data analytics. And once the results are obtained from data analytics, then we can start integrating it to the tools like Looker Studio or Looker, etc., within the GCP ecosystem itself. As you can see on the screen, there are two different words, Looker Studio and Looker. So you are seeing them correctly because actually these are two different platforms from the perspective of implementing the data visualization. So let's dive into these two important platforms that allow us to achieve data visualization. So the first one we are picking up is the Looker Studio. And then we're going to be discussing the Looker platform. But before we begin talking about each one of them, it is important to know how are they different from each other. So Looker Studio was previously called as Google Data Studio. This was a free standalone Google product, which was later brought into the GCP umbrella to be integrated with the data analytics tools or to complement with the data analytics tools. On the other hand, the Looker is an enterprise-grade business intelligence platform, which was acquired by Google in 2020, and it is also deeply integrated into the GCP ecosystem for advanced data modeling and analytics. So, given the use case, we may be implementing the Looker Studio or Looker, depending upon what are we actually trying to accomplish in our complete data visualization tasks or complete set of data visualization tasks rather. So let's come to the first one, which is Looker Studio. So through Looker Studio, we can accomplish data visualization, we can plot graphs, we can create the outcomes like the bar graphs, let's say the heat maps, etc. And through this, we can aggregate or collect these visualizations and perform what is called as dashboarding. So typically, we can create interactive, shareable dashboards and reports using Looker Studio from the data sets which are outcomes of our analytics implementations. The analytics implementations were done on BigQuery, and the visualization is being done on Looker Studio. So that is a point to remember over here. Followed by this, Looker Studio also allows us to perform real-time data insights. It can seamlessly connect to the real-time data sources, which allows the stakeholders to monitor metrics without manual updates. So for example, an application deployed on, let's say, a given virtual machine instance, and the log data of that virtual machine instance is being processed through a given data processing pipeline, and the resulting relational data getting analyzed on BigQuery and the outcomes getting visualized on Looker Studio. So what was said just now represents back-to-back steps to allow real-time data insights and seamlessly connecting Looker Studio to the real-time data sources on GCP. The last point to wrap up Looker Studio would be its easy collaboration and sharing. So this allows built-in collaboration tools to be allowing collaboration with not only BigQuery, but with other platform or set of platforms as well. And hence the insights which are built on Looker Studio can be shared across the organization internally or outside of organization for the targeted collaborations. So overall, we have already discussed that the dashboarding and report creation, which are two important implementations for data visualization, they can be accomplished on the GCP platforms like Looker Studio. Followed by this, it is important to outline set of best practices for the data visualization typically that needs to be adopted and would help for better comprehension of the data sets which have been analyzed on platforms like BigQuery. So the first important practice is choosing the right chart type. So we want to choose the visuals which match our data purpose very well. So for example, the line charts can be adopted for representing or depicting the trends over time. The bar charts can be implemented for the comparisons across the different entities within a given data set. Pie charts can be used for the simple proportions typically. So choosing the right chart type, right visualization type is an important practice that needs to be considered. Another one is to keep the visualizations clear and simple, to keep them clutter free, to have readable labels, to use the colors carefully, and to allow the overall comprehension of the visualization by the users and the understandability of the data in effective manner. And last but not the least would be focus on key insights. So out of all the data analytics outcomes, the given use case would have key insights, key outputs that need to be depicted through visualization. So prioritizing those key outputs is another important practice that is helpful for effective data visualization. To conclude this section with the real world scenarios that allow us to understand data visualization better would be, say, for example, the business performance dashboards. The management, the authorities, or even the stakeholders at whatever stage of a given project in an organization would prefer to have visual dashboards to monitor outcomes like sales, revenue, and customer engagement in real time. Therefore, taking faster decisions based on the visualization outputs through those dashboards. Another real world scenario which incorporates data visualization intensely is healthcare analytics. So the hospitals across the globe implement data visualization to allow the visualization of patient data, the treatment outcomes, disease trends, which would overall help the stakeholders, the doctors, the let's say the healthcare providers to improve patient care and resource allocation. And the last real world scenario for this section, and an important one, would be the government and public policy creating authorities and the departments. One example would be COVID-19 trends, for which the dashboards were effectively created in the GCP ecosystem and were presented to the stakeholders and to the decision makers to allow effective decision making. Also represented the statistics, the population based outcomes, which would further be incorporated for deciding resource allocation, budget allocations through these interactive visuals, also to inform the outcomes or the uh, current status to the citizens, etc. Moreover, the same dashboards in the scenario of public policy and the government organization and departments can also be implemented for guiding the policy frameworks effectively. So these data visualizations, in simplest words, relay the outcomes of data analytics, and they relay and portray the data through reports, dashboards, with right choices of graphs and plots and visualizations, overall allowing the stakeholders to leverage the power for effect of the to leverage the power of data visualization for effective data driven decision making, as the insights can be derived from these visualizations. To summarize this entire discussion, let's pick up the key takeaways. from all what we've discussed through different sections. So in the beginning itself, we could see that how the Google Cloud ecosystem, which is offering multiple tools, empowers the user through the tools and technologies which allow the comprehensive analytics to be accomplished. And on these tools, which are part of the Google Cloud ecosystem, enable end-to-end data workflows to be designed, to be deployed, and successfully executed as well. Next, important take-home message would be that the data ingestion, the first part of this complete discussion or this presentation, where we discussed data ingestion, that part is extremely crucial because if the data ingestion has not happened effectively and correctly, then the downstream steps of data processing, transformation, analytics, visualization are nearly impossible because the data itself is not present and has not been ingested. So once this task is accomplished in the right manner through the tools like PubSub, cloud storage, etc., this then provides data for the next steps downstream, which would involve data processing, transformation, analytics, visualization, dashboarding, reporting, etc. The key point following the data ingestion would be data processing and transformation. And let's not forget, by doing this, we are shaping the data to make it more compatible with the tools, technologies, platforms like BigQuery, Dataflow, data flow pipelines, which would allow the outcomes of data processing and transformation for having the data which is cleaned, enriched, and with right schemas. Followed by this, the data is now in a shape to be taken forward for advanced analytics, and machine learning algorithms can be implemented in a seamless manner using the tools, technologies available on GCP like BigQuery ML, Vertex AI, etc., to allow the complex tasks of predictive analytics, pattern recognition, etc., and most importantly, the querying or asking questions to the data is now feasible as the analytics tools on GCP allow us to achieve the same. And last but not the least is the data visualization, which is going to help in transforming the outcomes of data analytics into actionable business intelligence or into actionable data insights that help the stakeholders to intelligently derive information which holds credibility and has the power for complete business transformation and positive outcomes in the businesses as well. With this, we would like to thank all the learners for their precious time and attention for this presentation. Thank you.
Thank you, Geetika. That was incredibly insightful. Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and webinar-related courses.
Thank you, Tracy. Insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the three leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So we, Netcom Learning, is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand-picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post-event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. You guys have a good one. Thank you.
Thanks so much for guiding us through that information, Ifla. And now we're going to go ahead and jump right into our question and answer session. How can conversational AI be leveraged for data analytics on GCP platform?
Yes. So the conversational AI is where you want to be chatting with your data. So let's not forget that not anybody and everybody can write SQL scripts, because that involves SQL background knowledge. So what if there is a user who has no SQL background and they want to be performing data analytics on Google Cloud ecosystem? So in today's world, the conversational AI can be leveraged through GCP ecosystem itself. So the data sets that are currently present on BigQuery, to those data sets, we can ask questions in natural language. So we can simply type English text and query the data set. And once the query is taken in by the system, it is going to automatically fetch answers from that data set present in the BigQuery. To summarize this information, overall, in 2025, GCP is offering its users the option of conversational AI to be able to chat with your data, which is a very empowering implementation, especially for the users who do not have SQL or SQL background. Thank you.
What is a schema in BigQuery?
The schema in BigQuery represents the data type for a given column header. For example, if a data set has 3 columns, name, age, and city, so name will be string data type, age will be integer data type, and city would be string data type. So the schema is going to be the column header, whatever the title is, and its corresponding data type as well. Along with this, there can be other details also, but this is the bare minimum that represents the schema. Thank you.
How are connections created for data transfers within GCP and tools outside of GCP?
Right. The answer to this is that there is a big list of making a big list of tools that can be leveraged by the organizations to allow the data transfers to happen when the data is present outside of GCP. And within the GCP, there are inbuilt tools from the GCP ecosystem that can be leveraged to perform the transfers. So depending upon the use case, if data is present outside of GCP ecosystem, then tools like transfer service can be leveraged for making the connections and transferring the data. And within the GCP ecosystem, like BigQuery service, it would have its connectors to be used for connecting to the services within the GCP. Thank you.
What third-party tools can connect to BigQuery for data visualization?
There is a big list of third-party tools that can be connected to BigQuery for data visualization, and also the programming platforms that can be integrated with BigQuery for data visualization. One tool or one platform that can be connected, which is third-party platform, is Qlik, starting from Q, Qlik. And one programming platform that can be integrated with BigQuery as an example for data visualization would be R. So R-based programming for data visualization can be implemented and integrated with BigQuery platform to perform data visualizations. Thank you.
What are the security and compliance considerations for data analytics pipeline?
Thank you. This again has two parts, the security and the compliances. So these are two separate parts, and each part has its own big list of best practices and implementations to be performed. But we will pick up one example for each in this discussion. So for security purposes, it is important to know that security on GCP is a shared practice. So GCP has its own international standards of security implementations for ensuring that the customer data is safe. But at the same time, the customer and the user is also responsible because of the shared responsibility model to ensure that their practices are also in place to accomplish security. One example of those implementations and practices is the credentials. So every user who is using GCP platform for their data analytics pipelines on the Google Cloud Platform ecosystem, they need to be conscious about securing their credentials. For example, the username and the password. If the username and password are stolen, then that can jeopardize the work or the data on the GCP ecosystem set up by that particular user, especially if the MFA, multi-factor authentication, is not existing and is it not in place for that particular task or use case, say for example. On the other hand, coming to compliances, again, it's a big list of compliances as per international standards that GCP services follow. So one example would be ISO compliances, which are followed by the GCP, and from their side, we as users are in a position to understand that those compliances are in place. But again, we as users also need to be compliant and have the set of best practices in place. So one example of that would be the regulations of a given location, geographical location for data handling that needs to be in place. So we need to be compliant by the rules, policy of data handling, data sharing, data privacy-based implementations for that particular geographical location where we are actually operating our, or on which we are actually operating our GCP services for. So both security and compliances are a shared model implementation where the GCP is offering its own practices to the users and are in place for the GCP services. At the same time, user is also responsible to implement key practices to overall keep their data, their solutions safe. Thank you.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.